So the focus of this section is to find areas or probabilities, or you can think of them as relative frequencies over the long run, that correspond to various regions under the graph or the curve of the standard normal distribution. So to do this, we're going to also take a look at z-scores and then see how that corresponds to specific areas under the curve. Now, there are lots of different types of distributions and probability distributions out there. And here you can see a screenshot of all the different types of distributions that we can have. And the type of distribution just depends on the type of data that you collect. But in this class, because we're limited due to time, we're going to focus on data that have a normal distribution, so data where the distribution is bell-shaped. And then we'll later talk about the student t distribution. You can see that that distribution is also bell-shaped. And then today, in this lesson, I'm going to also focus on an example of a distribution that's uniform, just so that you can kind of see the difference between uniform distributions and normal distributions. So just real briefly, whenever you have a uniform distribution, this is a distribution where you take a look at your random variable and then you look at all the possible outcomes for that random variable. And if every single possible outcome has the same probability of occurring, that means that each possible outcome has the same chances of occurring, then you'll see that the frequency bars for every single possible outcome is going to have the same height. And so that creates a distribution that looks rectangular. But the big idea here is that the area under the curve, right, corresponds with a total probability that is going to be equal to 1. Okay, now when we take a look at a normal distribution, this is looking at data where when you look at all the possible outcomes, they don't occur at the same with the same frequency or with the same probability. And so that's why the frequency bars, the heights, are going to vary. They're going to be different. But what makes it a normal distribution is that the highest frequency bars are going to occur in the center of your distribution, where we're going to find the mean of our data set. And then as we look at variables that move, or when we look at all the possible outcomes that are moving away from the center, you can see that the frequency bars get lower and lower. And so the probability gets smaller. But again, the main idea here is that anytime we have this probability distribution, the entire area under the curve has a total area or a total probability of 1. Now, when we take a look at a standard normal distribution, you'll see that a standard normal distribution is also bell-shaped, just like the normal distribution. But the difference between a standard normal distribution and then just a normal distribution is a normal distribution is going to vary depending on the data that you collect. And so, for example, if we're collecting data about height measured in inches, it's going to have a very specific mean and a very specific standard deviation. If I were to collect data on, let's say, weights of college students, that would be another normal distribution with a very specific mean weight and mean, standard deviation for those weights. When we're talking about a standard normal distribution, what we mean by standard is when we take the normal distribution, so above here, I've got an example of a normal distribution. And we take all of these values and convert them to, a z-score. So we standardize those values. So in this particular example, I take the height measured in inches and I convert all of those heights to their corresponding z-scores. So when we do that, we call this distribution the standard normal distribution. So we can create a standard normal distribution for any normal distribution. And the unique characteristic of a standard normal distribution is that the mean is always going to be 0. Okay, so that's the value in the center of your distribution. And your standard deviation is always going to be 1. So here we see that a z-score of 1 means you're 1 standard deviation above the mean, and a z-score of -1 means that value is 1 standard deviation below the mean.